The next question gives you a distribution with a mean of 158 and standard deviation of 57. Okay, if z, the question arises, well, first of all, the question is, if z equals 1.3, then what's the value of x? The first thing you want to do, and you should do this if you haven't already done this, is relabel the axis for the x values. We draw a normal distribution and then we relabel the x-axis. So the x-axis is going to be labeled at the mean when z equals 0, that's 158. Then we add 57 to get the z equals 1 value, because of course every change of z is the number of standard deviations. So one standard deviation corresponds to a change of 57 units. So 158 becomes 215 for z equals 1. And then we add 2 times 57 to get 273 for z equals 2. We do 158 minus 2 times 57 for z equals minus 2. Now there's a formula. We could write this as a formula, but this is just common sense, and you're much better off understanding the common sense than you are following a formula that you don't really completely understand. So I do recommend that you understand the common sense of this relabeling. Okay, well now, one way or another, if z equals 1.3, then the question is, what is x? Well, let's see. Now z equals 1.3 is about here, isn't it? Okay, so we know that the x value is going to be between 215 and 273. Now we had one student that said, okay, well, it's 57 between here and here. If we make tick marks at point 1, at 1.1, 1.2, all the way up to 1.9 and then 2, each tick mark is going to be 1/7 of 57, or 5.7 from the preceding. So 3 tick marks will be 3 times 5.7, and that's going to be 17.1. And that's certainly one way to do it. Another way is just to understand that, that's a good way. It represents a good understanding of what the labeling means. Now, a little more, little shorter method, and one that isn't difficult to understand if you understand that, is, okay, z equals 1.3 means 1.3 standard deviations from the mean. Okay, what's 1.3 standard deviations? We want to find the x value that corresponds to z equals 1.3. Well, 1.3 standard deviations is 1.3 times the standard deviation, 57. If we multiply that out, we get 74, approximately. I could be off by 1. I could be off by a lot more than that, but I don't think I'm off by more than 1 there. Okay, so 74 corresponds to 1.3 standard deviations. There's 1.3 standard deviations, and that's going to correspond to 74 x units, which means that we're going to take the mean and we're going to add 74 to get the x value here. So the mean plus 1.3 standard deviations is 158 plus 74, which comes out 232. So that x equals 232 corresponds to z equals 1.3. And now we know, if we want to find out, if we have a good z table, it'll tell us the area between 0 and z equals 1.3, which tells us what percent of, or what proportion, depending whether you want to think proportion or percent, of the outcomes of this, what percent of our x values will lie between 0 and 1.3, or 0 and 232. Okay, just find the area between 0 and z equals 1.3, and in this case, that's the area between x equals 0 and x equals 232. And we'll talk more about how that is interpreted.